Hey everyone, and welcome to AC Academy. Today we're going to be going over Algebra 1, Section 2.1.5, explaining exponential functions, the second part of that, which let's go ahead and dive right into, okay? So question 1 states, the amount of inventory a store has of a given product decreases at 3% per week. So let's underline that, 3% per week. Zoom in slightly so you can see better. The store initially had 50,000 of a given product. Write a function that models the amount of a given product after W weeks. Okay, so two things, just like I did in part 1. Let's go ahead and write a table where we have X, or sorry, rather we have W, and then we have the product. So let's say P. Okay, so week 0, week 1, week 2, and then we'll go down to week W. We know at week 0, so the initial starting amount as underlined here, the amount of product is 50,000. And we know from week 0 to week 1, it's going to be minus 3%. Okay, so let's go ahead and do 50,000. Let me write out actually what I'm putting in the calculator. 50,000. Okay, minus 3%, right? Or rather, we want 97% of 50,000. Okay, so that'd be 0.97, right? Because 50,000 times, like if we want 100% of 50,000, that would be 50,000 times 1, right? So 1.00. If we want 3% less than that, or we want 97%, right? That's the equivalent. So 50,000 times 0.97 gives us 48,500, and that's the amount we'll have here. And that's really all we need to solve this problem, and we can do W, right? So let's say P of X, or sorry, I keep putting X, P of W is going to be equal A to the N X. Okay? Using the table here, we know that A, when X equals 0, this thing goes to, whenever X equals 0, or rather let me do P of 0, right? And I keep writing X, sorry. P of 0 equals A, which is 50,000, or let's say we don't know yet. A, N of 0. N of 0 equals 1. We know that P of 0 equals 50,000 equals A, right? So we know 50,000 equals A. So P of 1 equals 50,000. We're just plugging in. N, we got to solve for N. N of 1. We know N, anything to the first power is itself. So that equals 50,000 times N. And P of 1, as we solved here, is 48,500. Writing it down here, N equals 48,500 divided by 50,000. So we know that N will equal 48,500 divided by 50,000. So N equals 0.97, right? Same thing we did up here. So we technically solved for it here, but I kind of wanted to walk through the steps. So now we have an equation. So we have P of W is equal to A, 50,000, times 0.97 to the W. Okay. Hopefully that makes sense. If not, again, put it in the comment section. Same thing here. Let's go ahead and set this up. We have H hours. Let's say C for cells. The number of cells within a container doubles every hour, right? The container initially has 4 cells. So at t equals 0, it has 4 cells. Create an equation describing the number of cells within the container after h hours, right? So C of h is equal to A, and then you have some percentage, and then h is the number of hours, right? We solve, in same thing in the problem above. Let's say C of 0 equals A n to the 0, n to the 0 equals 1. We know that initially there are 4 cells, so then we know that A equals 4. C of 1, 4 times some n number to the 1 equals, we know the container doubles every hour, so 4 doubled is 8. We know that 8 here. Okay, n to the 1 is n, and that equals 4n. We know that n equals 2, right? Divided by 4, divided by 4, n equals 2. So solving for this equation, C of h, and this is just plugging in 4, 2 to the h, okay? Hopefully that makes sense. Again, if you have any questions over this, put it in the comment section. I'll do a section review video covering the questions and whatnot. So, yeah. Anyway, thanks for watching. Again, any questions, any personal homework problems, go ahead and let me know. Then I can work them out. And I'll see you in the next video.